Good evening, everyone. I will start the session in 10 minutes as no one has joined. So I'll wait for some time and then start the presentation. Okay, so now we'll start the today's session. So welcome to the week 8 session of Biomass Conversion and Biorefinery. The course coordinator for this course is Professor Kostamohanty from the Department of Chemical Technology, IIT Guwahati, and I, Aryant Ahuja, a PhD scholar in the Department of Paper Technology, IIT Roorkee, will be your today's TA. Currently, I am doing PhD under the guidance of Professor Vibhor Kumar Rastogi in the Department of Paper Technology, IIT Roorkee. So, we'll start the session by solving the week 8 assignments which you have done, submitted this week, and we'll go behind the reasoning of the answers that why uh, we will go to in the reasoning of the answers of week 8, and then we'll move on to the week 9 preparatory questions so that you could solve and submit your week 9 assignments easily. So let's start with assignment 8 of 2023. The principle of Kf titration is based on the Bunsen reaction between. So Kf titration, this is a method which we use to determine the presence of water inside oil. So if a biodiesel has any amount of water, KF titration is the most used in method industrially. And there is another method of FTIR through which we can determine the presence of water. So, but KF titration is the most used industrially. So the main principle of this process is the reaction between iodine and sulfur dioxide in an aqueous medium. So KF titration is a short for Karl-Fischer titration, and it is a method used for the quantitative determination of water content inside a substance. This method is based on the reaction of water with iodine and sulfur dioxide in the presence of organic acids. The titration involves the addition of Karl-Fischer reagent to the sample until the water is consumed. So the higher amount of reagent used means the higher amount of iodine and sulfur dioxide used, the higher the amount of water in it. So the amount of Karl-Fischer reagent consumed in the titration is proportional to the amount of water present in the sample. Therefore, this reaction is based on the reaction of iodine and sulfur dioxide. So let's move on to the next question of assignment A. Usage of water as supercritical fluid for hydrothermal processing results in. So first of all, what is this hydrothermal processing? Hydrothermal processing is a process in which we used to extract some compounds, oil compounds from our product. So the biodiesel or bio oil has has some impurities and purities. So in order to extract the oils from the product, we use a process known as hydrothermal processing, in which a solvent is used, and this solvent is mostly uh, polar solvents, and the solvents extract the oils at high temperature and pressure. But what if we use water as a supercritical fluid in this process? What if the polar solvent in this is water? So, water and oil, we know that these two things do not mix. It will form a phase separation of oil at top and water beneath it. So, water cannot solubilize oil. So, therefore, there will be a lower yield of water insoluble oil products because less amount of water insoluble oil will be extracted from the product. So now let's move on to the theory part of it. Hydrothermal processing involves heating aqueous slurries of biomass or organic waste at elevated pressure to produce an energy carrier with increased energy density. So under these conditions, under these high pressure and temperature, the carbohydrates or lignin present in the biomass undergo depolymerization and fragmentation reaction to form variety of products including bio-oil. But if water will be used as a supercritical fluid, then it will be less effective. Why? Because water is of high polarity. So the high polarity of water makes it less effective in dissolving non-polar compounds such as hydrocarbon. And as it will dissolve less amount of non-polar compounds, so therefore uh, water insoluble oils will be lesser extracted. Therefore, the yield will be less. Moreover, there is one more disadvantage to this process, and that is that presence of water also leads to high viscosity. So the presence of water leads to high viscous oil as it dissolves polar compounds present in the oil. So water will dissolve the polar compounds present in the oils, and hence a very high viscous oil will be get. So this is the second disadvantage of using water. So if we use water as a supercritical fluid, first disadvantage is low yield. And what is the second disadvantage? It is high viscous oil, formation of high viscous oil. So to overcome this, we use some organic solvents for extraction such as ethanol and butanol. So for extraction of oil, for extraction of bio oil, we will use ethanol and butanol, as these are some polar solvents which can dissolve the bio oil. So therefore, these two are the major organic solvents used to extract bio oils. Now let's move on to the third question. Slow cooling of the volatile compounds enhances the collection of which type of compound in the oil? So, in pyrolysis, if we do a slow cooling process, some compounds are precipitated and due to the polymerization. Those are lignin derived compounds. So, the theory behind is that slow cooling can lead to preferential collection of lignin derived components. When the liquid is slowly cooled, lignin-derived components further condensation reaction. So there is a condensation reaction during this slow cooling, and this lignin will get polymerized. And this polymerization will lead to formation of solid compounds, solid lignin compounds in the form of polymer. So which leads to formation of larger and more complex molecules, and thus the lignin is precipitated. Therefore, slow cooling is not preferential, as the lignin will be present in it. And these larger molecules are more likely to be insoluble in solvent, and thus they can precipitate out of the liquid and deposit as a solid. And when these will be deposited as a solid, the machinery part will also get damaged. So these solid deposits of lignin, the lignins which has been polymerized and have been solidified, they can be accumulated in the heat exchanger equipment and liquid fractionation, which will lead to blockage and reduce the efficiency. So therefore, slow cooling is not advisable during the pyrolysis. This is not advisable during the pyrolysis, as it will lead to polymerization of lignin, and thus the blockage will happen in the equipment. Therefore, the efficiency of the process will be reduced. Now, let's move on to the fourth question. What is a dominant mode of heat transfer in the fast pyrolysis method? So, by far, we know that what is a pyrolysis method. In a pyrolysis, we give a inlet gas which will heat inside it, and we also give some biomass feed in it, and these biomass are heated through the hot airs. So the heating of biomass through air is known as convection, and the biomass which has already been heated will heat the other biomass which is entering inside it. So the heated biomass will heat the uh, cold biomass. Both are biomasses particles. One is heated, which has been heated by the convection, and the other is cold, which is a new feed because this process is a continuous process. So this hot biomass will heat the cold biomass. This is due to the conduction, and also through the heated equipment. The equipment is also heated, so the conduction will happen from this also. Therefore, as the dominant mode of heat transfer is both A and B, conduction and convection. And this conduction and convection, if we look at these, that which might be more dominant, this depends upon the type of reactor. So different reactors have different uh, dominant mode. So in fast pyrolysis, both conduction and convection heat transfer plays important roles. Conduction is dominant heat transfer within the solid biomass. So solid biomass to biomass or from the equipment to biomass. While convective heat biomass is responsible for heat transfer between hot gases and biomass. And now in this table also we can see that if we look at the reactor type, that if it's ablative, circulatory bed, fluid bed, or entrained flow. So in this, we see that ablative type reactor have mostly conduction method. So 95% of the heat transferred is due to the conduction method, and wherever in this we see in enter and flow, 95% is by the convection method. So in this, air is mostly responsible for the heat transfer in enter and flow. The hot flow air will be flowed and it will uh, provide the heat to the biomass through hot air. But in ablative, there is a screw which pushes the biomass forward, and this screw is heated already. So the screw will be responsible for the heat transfer. Therefore, in ablative, conduction is the mode of heat transfer. So it all depends upon the type of reactor, that what is the dominant mode, whether it is conduction or convection. And radiation, we can see that it's not a dominant, it is always very less, that is 1%. So therefore the answer for this was conduction and convection both. Now let's move on to the fifth question of assignment 8. TGA is applicable for thermal analysis in which changes in physical and chemical properties. So first of all, what is TGA? TGA is an instrument which is known as, it is a short for thermogravimetric analyzer. So thermo means heat, which we can define by temperature, and gravimetric means mass, which we can define by weight. So this analyzer, what does it does is that we provide a sample to it and enclose in a closed environment and heat it. And while the mass is heated, it heats from room temperature to, let's say, 800 degrees Celsius. We will give the temperature from room temperature and heat it up to 800 degrees Celsius. And with the temperature, we will see the weight loss. That how much weight is being lost during this uh, temperature. So a graph is plotted like this. The x-axis is temperature and the y-axis is weight loss. And at room temperature, we will say that the mass is 100%. And as the temperature is increased, for example, if the temperature is increased up to 100 degrees Celsius, we can see a weight loss from 100 to, let's say, 95. If the weight loss is 100 to 95 at 100 degrees Celsius, then we can say that 5% is moisture or some volatile compounds. And then if there is a sudden decrease in weight loss, let's say it reached around 50% weight loss at 200 degrees Celsius, then we can say that it might be due to the depolymerization of the biomass. And further, if there is a more steeper decrease in the weight, then it might be due to the thermal degradation. And at last, after 600 degrees Celsius, after 600 degrees Celsius, if there is some amount of biomass present in it, that it is not coming to zero, it came to 2% only, and it is constant at 2%, then it means that that biomass had 2% of inorganic compounds. So it has inorganic compounds of by 2%. So this is done by TGA. So now let's move on to the question that in which in physical and chemical properties of material as a function of decreasing temperature, increasing pressure, increasing temperature, decreasing pressure. So now, as I have told that we will increase the temperature from room temperature to 800 or more also. We can go for more also. So it's a function of increasing temperature. So we see the physical or chemical changes with increase in temperature. This is a typical diagram of thermogravimetric analysis of a polymer. So here we are seeing that this decrease is nearby 300 degrees Celsius, and this shows that this polymer might have some high volatile compounds, some compounds which are volatile at higher temperatures. So this was nearby 96%, therefore the high volatile compounds are 4.4%. And then this might be due to the depolymerization, this steep change, and this might be due to the combustion, that finally the polymer has been combusted. And at last there is a percentage of ash 30%, means that at 600 degrees Celsius only ash is present. After that it remains constant. So TGA can be used to see the chemical or physical changes inside the polymer, and we can also estimate the amount of matter present in it. So now let's move on to the sixth question. The application of biochar significantly affects the absorption of phosphorus. So biochar is very useful for increasing the soil quality, soil improvement. We use biochar for improving the soil improve because biochar is a very good adsorber. So phosphorus can be easily adsorbed on the biochar, but if we alkali treat it, how will it affect the phosphorus absorption? So basically, after the alkali treatment of biochar, the absorption of phosphorus increases, and it has due to various reasons such as increase of surface area. So biochar has a very large surface area, and therefore it is used as a adsorber. But the alkali treatment increases it further. So alkali treatment will further increase the surface area, providing more adsorption site. Moreover, the pH during the alkaline treatment, the pH will increase. The biochar pH will increase. So this pH enhances the adsorption of phosphorus, which is more soluble and available in alkaline soil. So the phosphorus is adsorbed more on the alkaline side, and making alkaline biochar, phosphorus absorption is more increased. And finally, chemical reactions. So alkali biochar treatment modifies the surface chemistry of biochar. So there are some types of chemical changes on the surface of the biochar, which creates some kind of functional groups, and these functional groups easily attracts phosphorus. Therefore, this again increase the adsorption. So the new functional groups, the pH, and the increased surface area. These three happens due to the alkali treatment of biochar. Therefore, the adsorption of phosphorus on biochar increases, and hence it can be more useful in increasing the soil quality. Now let's move on to the seventh question. The pyrolysis front moves in which direction in the ablative reactor? So first of all, we know that what is pyrolysis. Pyrolysis is a equipment, is a process in which we burn the biomass in the absence of oxygen. But what is this pyrolysis front? So pyrolysis front is a type of boundary which moves with the in the direction of biomass going inside. For example, if this is a pyrolysis reactor and we insert the biomass from here, so the biomass enters here and it comes in contact with the hot air and this becomes heated. So this is the boundary created which at which there is a, we can say that partially pyrolyzed biomass. Now again some biomass will be entered from here and this will push further, so the boundary will go again upward, so the boundary moves in the direction through the biomass. Therefore the answer is unidirection through the biomass particle. I will explain this more in the next slides. So the pyrolysis front refers to the boundary between solid biomass feedstock and the pyrolysis products. So the pyrolyzed solid particles, so the pyrolyzed biomass and the biomass. So the boundary between these two is known as pyrolysis front. So it is a region where the temperature is high enough to cause thermal decomposition of biomass. And what is a ablative reactor? Ablative reactor is a type of pyrolysis reactor in which biomass feedstock is heated in the direct contact with hot surface, such as rotating drum or moving bed of sands. So in this, there's a screw which helps to move the biomass in forward direction, and thus this boundary moves in the direction of biomass movement. Therefore, the answer was unidirection in the direction of biomass. So the boundary will also move as the screw moves the biomass forward. So as the biomass particles heat up, they begin to paralyze with the reaction front moving through the particle. So the biomass front was this, and as there will be more biomass entered here, this will move more forward. This front will move forward, and this moves in the unidirection of biomass. Now let's move on to the eighth question. The major disadvantage of utilizing water as a solvent for liquefaction of biomass is. Now, in the starting also we have seen that water is a very highly polar solvent and it cannot dissolve oils present in the biomass which we obtain from the biomass. So this, the use of white water will lead to very low yield because it is not able to extract oil. Oil and water doesn't mix with each other, so it will be responsible for low yield of water insoluble oil products. Also, water will dissolve some polar compounds. As water is polar, so it will dissolve some polar compounds. And the polar compounds usually increases the viscosity. So any type of viscosity enhancer which are present in the market are mostly polar. So if water will be used for the as a solvent, it would dissolve some polar compounds and hence the viscosity will get increased. Therefore, it will yield a bio oil that is very highly viscous with a high oxygen content. Therefore, the answer is both A and B. So, Water as a solvent, we have seen that it has various disadvantages. First, it results in low yield of water insoluble because water is highly polar, and therefore it is less effective in dissolving non-polar compounds. It cannot dissolve non-polar compounds. Therefore, it will yield in lower yield of water insoluble oil. Second disadvantage is that it will yield to very viscous bio oil with a high oxygen content, and these two, therefore water is not usually used, and we use some other polar compounds such as ethanol. Ethanol is also a polar compound, but it can dissolve some types of oil at very low concentration. It can dissolve oil with at a low concentration, but at increasing the pressure and temperature, we can increase the solubility of oils in ethanol. Therefore, uh, ethanol or butanol are used for the extraction process of oils at a higher temperature and higher pressures. Now, let's move on to the ninth question. Which reactor configuration is preferred in biochar production? So, there are many types of reactors we have seen now, that there is ablative reactor, auger reactor, bubbling or circulating. So, among these, auger reactors are the most preferred for biochar production, and these are mostly used because they are easy to manufacture and is cost effective for smaller industries. So if industry is very small, they can use the auger reactors, which are easy to use and easy to manufacture and is a low cost also. So auger pyrolysis reactor are getting increased attention from small or mid-scale industries, and in auger reactor, a biomass is continuously fed to a single or twin screw, and then auger rotation moves the product along the axis of the heating zone. So this is a particular uh, diagram of an auger reactor. There is a motor here, and the biomass is added to the hopper from the top, and the motor is used to drive the biomass in forward direction. And during this method, the screw, this is a type of screw in which the biomass will rotate, and this during this rotation, the heat is also provided from the outside, and then the biomass heating is done in this auger reactor. After this, we condense it and then obtain bio oil and biochar. So this is the most easy to use and inexpensive method, therefore used by many mid-scale or small-scale industry. Now let's move on to the last question of assignment date. The fixed carbon content of raw biomasses is generally in the range of. So first of all, what is this fixed carbon content? We all know that biomass is a carbon-rich material. It is made up of carbohydrates and proteins or uh, any acids, but it also has some kinds of impurities in the form of volatile compounds. So these volatile compounds are also carbon-rich material. So when a biomass is heated until all the volatile is removed, we remove all the volatile compounds, and then we will get a very solidified biomass. The amount of carbon present in it is known as fixed carbon content. Okay, so this amount of carbon present in this solid biomass, which does not have any kind of volatile, which does not have any kind of volatile, is known as fixed carbon content. So the fixed carbon content is generally in the range of 10 to 30%, and this range depends upon the various types of biomasses also. So the fixed carbon content of a raw biomass refers to the carbon content that remains in the biomass after it has been dried and all the volatile matter has been removed. The fixed carbon content of raw biomass can be varied depending upon the biomass, types of biomass, and from where it has come. And generally, it is in the range of 10 to 30%, which means that 10 to 30% of the total weight of dried biomass is carbon rich, and rest of the carbon might be in the volatile, which have been removed. And this fixed carbon is majorly made up of cellulose, hemicellulose, and lignin, which is collectively known as lignocellulosic biomass. So, the amount of carbon present in lignocellulosic biomass is known as fixed carbon, which is generally around 10 to 30% depending upon the type of biomass being considered. Now, we will move on to the week 9 preparatory questions. There are some questions which I'm discussing here, and they will help you to answer the assignment of week 9. So, first question is, what are the advantages associated with alkali pretreatment of lignocellulosic biomass? So, first of all, what is this alkali pretreatment? We know what are lignocellulosic biomass. It is a biomass which has cellulose, hemicellulose, and lignin. And alkali treatment means treating this biomass with NaOH, which is a alkali, in order to separate the lignin or hemicellulose from the means we have to just separate these three things from the biomass. So we know that we are removing hemicellulose and we are also removing the lignin just to obtain the cellulosic to separate the cellulosic out of it. And another advantage of alkali pretreatment is low temperature and pressure. We do not need high temperatures compared to acid treatment. So the major advantages, all three: removal of hemicellulose, removal of lignin, and use of low temperature and pressure. So this is a typical block diagram of the alkali pretreatment. We treat the biomass with the presence of NOH, and this NOH is used to remove the lignin and hemicellulose from the biomass. And what we get here is we will get a cellulosic biomass, cellulosic fibers, and this will have some amount of NaOH also. So we will do washing with water, and then we will get is low concentration of NaOH. So here during the treatment we will get a high concentration of NaOH, and after washing we will get low concentration of NaOH, which we can recycle again and we can reuse again for pre-treatment. And after this we will get pre-treated biomass, which is mostly cellulose. Most of the lignins have been removed in this process, and some hemicellulose is also removed, some type of hemicellulose. Mostly we will get is cellulose here. So the advantages associated with alkali pretreatment are that alkali pretreatment can break down the hemicellulose fraction, making it more accessible to enzymatic hydrolysis. And second is removal of lignin. That we can also remove the significant portion of lignin from the biomass. Not all the lignin is removed; only some lignin is removed. Thus, therefore, sometimes if the lignin content is higher, after this chemical alkali treatment, we also do bleaching just to remove all of the lignin if biomass is very rich in lignin. Otherwise, alkali pretreatment is sufficient for the removal of lignin from the biomass. So, lignin is a complex polymer and it interferes with the cellulose. So, the cellulose fibers, there will be fibers, and the lignin will protect these. So the enzyme cannot attack on it. So in order to free the cellulose from the lignin, we do alkali pretreatment. And alkali pretreatment can be performed at very relatively low temperature and pressure, making it an attractive option for industrial scale. So this is the most used method by industry. Alkali pretreatment is the highly used in industries. Next question is the ABE fermentation is a biphasic process that converts. So before going on the answer, I will explain you what is ABE fermentation. So ABE fermentation refers to fermentation of a mixture of carbohydrates such as starch, cellulose by certain bacterial strains to produce acetone, butanol, or ethene. Therefore, the name has come ABE. So to produce acetone, butanol, and ethanol by the fermentation of starch or cellulose is known as ABE fermentation. Okay, so and what type of fermentation it is? Mostly we use anaerobic fermentation, and it occurs in two phases. First is acidogenesis, and second is solventingenesis. So in the acidogenesis phase, sugar is converted to organic acid. From this word, we can see that this word acidogenesis, there's a word acid in it. So it is this process converts sugar into organic acids such as butyric or acetic acid. And in the second process, solvatogenesis phase, the organic acids are converted into solvents such as acetone, butanol, and ethanol. Therefore, it has two phases. Now, if we go on to the question, ABE fermentation is a biphasic. Biphasic because it has two phases, acidogenesis and solventogenesis, that converts sugars into acids and solvent by two phases. So I hope that ABE fermentation method is clear, that it uses two it is methods. So the acid in the first phase, the acidogenic bacteria produce acetic and butyric acids from sugar, and then these acids go into the second phase, and the solventogenic bacteria will convert these acids into the desired solvent of such as acetone, butanol, and ethanol. So therefore, this is a two-phase process, and the term ABE has come from acetone, butanol, and ethanol. This is a typical diagram for the acid fermentation phase and solvent fermentation phase. So glucose or sugars or any type of carbohydrate is used as a raw material for it, and it is converted to acetyl. It is converted to pyruvate and acetyl coenzymes A. It is a type of coenzyme A, which is used to convert it into acetate and acetyl or the butyrates. So the enzymes used for converting the glucose to acid fermentation, it is converted to acids, and then these are converted to solvents. So mostly enzymes are used for these processes. The culture condition on which ABE fermentation is dependent on. So what are the culture conditions on which ABE fermentation is dependent? So the culture means the growth of bacteria or these enzymes or any of these microbes. So the microbes growth is most important during the fermentation, and the conditions at which particular microbes grow are defined by pH. pH, if we increase or decrease the pH, the microbe cultivation can be inhibited, and these microbes also require some type of nutrition. If these nutrition are we cut off or there's a shortage of nutrition, these microbes might not grow properly, and also product inhibition is more important. Therefore the answer is all of the above. So all the conditions are necessary for to culture the microbes used for ABE fermentation. So the culture condition on which ABE fermentation is dependent on all of the above conditions. such as pH, product inhibition, or nutrient shortage. And the optimal condition of pH is between 4.5 to 5.5. So this is the optimal pH at which the this fermentation process is done. And nutrition shortage can also limit the growth of fermentation activity of the microorganisms involved. Therefore, all these conditions are necessary to control the fermentation process. So, now the next question on ABE fermentation is major disadvantage in using distillation for every product recovery of ABE fermentation is. So, for by now we have seen that ABE is used to make three different types of solvents. But to purify them, we do not use distillation because distillation at every stage will be very high cost investment. So to provide distillation unit for every step will be a very high cost. So therefore, this is the major disadvantage. Further, this distillation process at every stage will also incur high energy consumption. Therefore, answer is both A and C. So distillation is a high cost method. We all know that. Therefore, the major disadvantage is this. Secondly, high energy consumption is also a major disadvantage because the solvents produced during the fermentation have low boiling point and form. They can also form azeotrope, which makes it difficult to separate through simple distillation. Therefore, some additional energy will be required for the separation of the azeotrope and purify the solvents, which will lead to higher energy consumption and operational cost. Therefore, distillation is not used majorly in separation of these solvents. Now, the next question is in the whole grain and residual components are separated at the end instead of beginning of the process that is called as. So, in dry milling, um, the grains and the components obtained from it, residual components obtained from these grains, are separated at the end. While in the wet milling, this type of separation is done at the start only. So, therefore, the correct answer is dry milling. But first of all, what is dry milling? Dry milling is a process in which entire corn kernel is cleaned, tempered, and ground into a meal. And then this meal is added to water and then slurried to form a mash. And then enzymes are added to the mash to convert starch to glucose, which is fermented to ethanol and carbon dioxide. And the solid remaining after the fermentation are centrifuged to remove the residual liquid. So this removal of the solids is done after the fermentation in case of dry milling. So in dry milling, the corn kernel components are not separate before processing, unlike wet milling where the components are separate before further processing. So to understand wet milling also, I have a similar questions in other slides also. I will explain the wet milling in these upcoming slides. So this is a particular diagram of dry milling in which a grain such as corn is milled and then it is liquefied where it is uh, treated with water and then cooked at high temperature and pressure and so that we can get liquid sugars or we can say dissolving grade sugars which is known as saccharification. And after this, we can ferment it to produce ethanol. Major product is ethanol, which we are doing. And after obtaining the ethanol, we will we will separate the kernels at the end with the help of centrifugation. So the separation is done at the last in case of dry milling. Now let's move on to the next question. What is the disadvantage associated with dilute acid treatment of lignocellulosic biomass? So, in previous question also we have seen what is alkali pretreatment. Now there is similarly we have a process known as acid pretreatment. Acid pretreatment is also a method to remove the lignin and hemicellulose. It can also remove the lignin and hemicellulose at high temperature and high pressure. But if we use a dilute acid, this process is not that much optimized, and lower amount of lignin will be removed. Not all lignins will be removed. Therefore, the answer is little lignin removal. This is the major disadvantage of dilute acid pretreatment. We cannot also use a very concentrated acid pretreatment because the concentrated acid will degrade the cellulose, and cellulose is of important use because we are utilizing the cellulose for bio oils and biofuels. Therefore, concentrated acid, we cannot use concentrated acid, and dilute acid will have a disadvantage of little removed lignin, which will inhibit further fermentation process. Therefore, alkali pretreatment is mostly used by industries. So this is a typical acid pretreatment of lignocellulose biomass. With the help of acids, we can separate the cellulose, hemicellulose, and lignin. And these lignins are then converted to phenols, and hemicellulose are converted to hexoses and pentoses, which are soluble sugars, or we can say monomeric sugars. And phenolics are some phenolic lignins are also some type of dissolving grade lignin, which are partially chemically changed. So, but the major problem with this is that not all lignin is separated in case of low acids, and in case of high acids, cellulose is degraded, and therefore hexoses and pentoses obtained are very low yield. So this is the major disadvantage of low acid and high acid both. So dilute acid pretreatment is a process in which biomass is treated with dilute acid to break down complex structure of hemicellulose and cellulose, making them more accessible to enzymes. However, lignin is a very complex and highly cross-linked polymer, which is less susceptible to acid hydrolysis and remains largely intact. Therefore, little lignin removal occurs during this low acid pretreatment. And this is a disadvantage because lignin can interfere with enzymatic hydrolysis of cellulose. Now, if there is amount of lignin present, if the cellulosic fiber has any type of lignin in it, this lignin will not help the enzymes to interact with the cellulose. This lignin is a very sticky substance. It is a polymer type substance which is a very sticky, and it will not allow the enzymes to access the cellulose structure. Therefore, it will act as a blocking to the enzymes, which can reduce the efficiency of the bioconversion process. Additionally, lignin can also inhibit microbial growth and fermentation during the downstream process. Therefore, a more effective lignin removal process may be needed to improve the efficiency. So, alkali treatment are mostly used. There is another method known as organosol treatment, in which we use organic solvents such as acetic acid or ethanol, and these organic solvents are also now being researched in order to remove the lignin, because this process removes the lignin in its own original form. Like we have seen that acid hydrolysis convert them lignin into phenolics. It is changing the chemical structure of lignin. So the lignin, we cannot use those phenolic lignin anywhere else. But the organosolved lignin removes the lignin in its original form, and thus we can use that lignin in any other application also. So alkali pretreatment are a commercialized process, and organosolves may be the future of this process. So this question is on wet milling. As we have discussed in dry milling, that the separation is done at the end, but in the wet milling, the separation with the kernel is done in the starting itself. So if the in this the grain is soaked in water to fractionate into individual compounds such as starch, fiber, germ, and then processed separately. This process is known as wet milling. So, wet milling is a method for producing food ingredients and products by processing the raw material in a liquid stream, usually water. So, in this, the grain is soaked in water to soften and separate the components. So, we have just soaked the grain in water, and this grain will get softened, and therefore the separation will be done at this step only. So the separation of components such as starch, fiber, and germs are done in the initial phase, and then these are processed separately to produce a range of products such as corn syrup, starch, ethanol, and other foods. Therefore, um, wet milling process is mostly used as it will result in the high yield of products. But as it is a very complex method, so small scale industries do generally dry milling only. But there are very high advantages of wet milling, as we can obtain different types of products, as we have separated all the things in the initial phase only. So wet milling is commonly used in the production of corn-based products such as cornstarch and corn syrup. This is the major thing which we do for wet milling. So the major difference between wet milling and dry milling is that we do the separation by soaking in the start only, and in dry milling we do the separation. We do this whole process without separation, and we will separate at the end. After we get the our bioethanol, we will separate the at the end by using centrifugation. Now let's move on to the next question. Cellulase. So it is not a cellulose, it is a cellulase. Cellulase is a mixture of enzyme that acts synergistically on to convert. So cellulase is an enzyme, and this word is given because it is used to convert cellulose into lower molecular sugars such as glucose. So the correct answer is cellulose and glucose. So we know what is cellulase. Cellulose is a complex carbohydrate, and it consists of long chain glucose molecules linked together by beta 1,4 glycosidic bonds. We know about the cellulose. So these are connected with 1,4 glycosidic bonds, and these are carbohydrates. And these are generally present in polymeric form. To convert the cellulose into biofuel, we need to convert the cellulose into monomer forms. So this can be done by some type of enzyme, and the particular enzyme which do this is known as cellulase. Cellulose is an enzyme which break down these bonds in cellulose to release glucose. So it breaks down this bond, and thus we can get individual glucose separately. So cellulase is an enzyme which is used to break down the cellulose into smaller molecules known as glucose, so that this glucose can be converted into biofuels. So cellulose is a high molecular weight homopolymer consisting of D and nitroglycopyrrose units together joined by, we have seen that it is joined by beta 1,4 linkages. So this is a particular chemical structure of cellulose, and this we can see that it connects. There is a bond known as COC linkage. We also call it ether linkage, and this COC is here. So C1O and C4. This one is C1, this is C4. Here also it is C4, it is here C1. So this connection between C1 and C4 by oxygen is known as glycosidic linkage or ether linkages. So therefore, these in this two monomers are joined by beta 1 comma 4 glycosidic linkages. So now let's move on to the next question. In vacuum pervaporation mode, a driving force is created by vacuum on the which side of membrane? So membrane is a porous material through which we pass some type of liquid with impurities in it. And on the other side, we get purified liquid which we want to obtain. And the impurities will either get into these pores, or the membrane will have some type of adsorber on which these impurities will get adsorbed. But this process is a slow process, and thus we need to apply some type of pressure. And in some cases, such as vacuum pervaporation, we can also apply a vacuum on the other side. Therefore, the answer is on the permeate side. So, a vacuum pump can be applied on the permeate side, and the feed will be given, and we will get the retenant here. So, this vacuum pump will take the permeate and to separate the inorganic, so to separate the impurities. So vacuum evaporation is a membrane separation process that uses a vacuum as a driving force. And by creating a vacuum on permeate side, the driving force is generated that pulls the volatile components. Now the next question is, transport in thermoperforation process can be facilitated by. First of all, what is this? Before moving to the answer, so TPV is short for transport in thermoperforation, which refers to a separation process where a liquid mixture is heated and then passed through hydrophobic membrane. So we have seen what is vacuum perforation. Vacuum perforation means in which we use vacuum to separate. And in thermoperforation, where the word thermo is come, we are using a type of heating mechanism. So in this, a liquid mixture is passed through the membrane, which is already heated. So liquid mixture is heated and then passed through a hydrophobic membrane under reduced pressure. So the separation is based on the difference of the vapor pressure in the composition of the mixture, which determines their permeation through the membrane. The driving force in TPV is both vapor pressure gradient and temperature gradient. So in vacuum permeation, we have seen that there is a difference of uh, there's a pressure difference created by vacuum, but in this process both pressure and heat, means pressure gradient and thermal temperature gradient, both are applied as a driving force in this separation process. So as a result, TPV can be used for separation of high sensitive compounds that would degrade under high temperature distillation process. So now if we see the question, TPV can be facilitated by, we have seen that it means that there's a relation between a temperature. So TPV can be facilitated by increasing temperature difference and decreasing the distance between the membrane and the cold wall. So as we decrease the temperature between the membrane and cold wall, the temperature gradient will be higher. And if temperature gradient will be higher, then the separation process will enhance. So That's all for today, and I hope these questions will help you to solve the answers of assignment 9. And if you all have any type of query regarding your assignments, if you're not able to solve any assignment, you can always reach me out. I'm sharing my email at the in the chat box. You can always connect to me, and if you have any type of queries regarding your assignment, please feel free to contact me. So, thank you. We will meet you in the next week, and in the next week. Hello, yes, 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 yes. Actually, I don't know about the exam type because we are just assigned for the tutorial question. But yes, I will let you know in the next tutorial. I will ask the NPTEL team, and then I will let you know. Yes, yes, yes. Mm-hmm. Sure, sure. I will let you know next week. I will ask the NPTEL team and will let you know in the next tutorial. Okay, okay. Thank you. So we'll meet you next week, and if you have any type of queries, please feel free to contact me. Thank you.